Since old hens can be brought at ₹2 each, and young hens at ₹5 each. But there are only ₹80 available, ₹80 available for purchasing hence then the constraint is then the constraint is 2x1 plus how much? It is 5x2 should be less than or equal to 80. 2x1 plus 5x2 should be less than or equal to 80. Fine. Since it is not possible to house more than 20 hens. How much? Not more than 20 hens. Then x1 plus x2 is less than or equal to 20. How much? x1 plus x2. x1 is what? Old hen. x2 is what? Young hen. So we cannot house more than 20 hens. So this also becomes one constraint. Since the profit is restricted to be more than ₹6. This means that the profit function x is to be maximized. So what they have told here, the profit should be more than ₹6. Means what? The profit function should be maximized. Thus there is no need to add more constraint. There is no need to add more constraint. That is 0.5 x2 minus 0.1 x1 should be greater than or equal to 6. So what is 0.5 over here? What is 0.5? Fine. 0.5 x2 minus 0.1 x1 is an objective function. Fine. Again, it is not possible to purchase quantity of items. Therefore, x1 is greater than or equal to 0, whereas x2 is also greater than 0. Fine. Finally, the problem becomes what here? Max z is equal to 0.5x2 minus 0.1 x1 subjected to the constraints. It is 2x1 plus 5x2 is less than or equal to 0. That is constraint number 1. Whereas next constraint is x1 plus x2 is less than or equal to 0, where x1 comma x2 are greater than or equal to 0. So this is what we got, the objective function. This is what the objective function. So once we got the objective function, we need to solve this objective function using graphical method. Fine. So once again I will start with this one. So this is what the problem is. Old hen is brought at 2 rupees, new hen is brought at 5 rupees each. Old hen lays 3 eggs per week, whereas young hen lays 5 eggs per week. But each egg is sold at 30 rupees, 30 paisa in the market. Fine. Whereas young hen and old hen, both hens cost over 1 rupees per week for its feeding, that is expenditure. And presently I have only 80 rupees in my pocket, so I want to buy both young and old hens so that my profit should be maximum, that is more than 6 rupees per week. I want to, really I am earning 6 rupees, but I want to earn more than 6 rupees. So assuming that I cannot house more than 20 hens. So what I do? So let x1 be the number of old hens and x2 be the number of young hens. But old hen lays 3 eggs and young hen lays 5 eggs. Then the constraint is what? 3x1 plus 5x2. Total number of eggs per week. The total number of eggs per week is 3x1 plus 5x2. So the cost of each egg is how much? 30 paisa in the market. So the total gain will be like 3x1 plus 5x2, that is total number of eggs into 30 paisa. So this is the total that we got. Then the expenditure means the feeding expenditure on the hens is 1 paisa per hen, that is x1 plus x2 is the total number of hens into 1 feeding expenditure. Then the total profit Z is earned by, that is the formula, total gain minus total expenditure, that is Z into this equation minus this equation, that is total gain minus total expenditure. So it is what? Z is equal to minus 0x1 plus 5x2 will become an objective function. But since old hens can be brought at 2 rupees and young hens can be brought at 5 rupees, but there is only 80 rupees available. So what happens? 2x1 plus 5x2 less than or equal to 80 rupees. We should buy the old hens and the young hens within the 30 rupees. This is also constraint. Fine. The next constraint is what? Total number of total capacity of housing hens is how much? 20. That's why x1 plus x2 is less than or equal to 20. So these are the restrictions. Then it becomes what? So no need to add any other variable. So then the objective function is like max z is equal to minus 0.5x2 minus 0.1 x1. Then subject it to the constraint 2x1 plus 5x2 is less than or equal to 80. How much it is? Less than or equal to 80. Then x1 plus x2 is less than or equal to 20. Fine. Whereas x1 comma x2 are greater than or equal to 0. So now we have just formulated the LPP. Now we are supposed to solve this formulated LPP using graphical method. Fine. Stop.